Hello and hello everyone. Today I'm going to take you through my term paper on the topic cattle surveillance and recognition using artificial intelligence. My name is Wasukera Ian and I'm from Makerere University, specifically from the School of Computing and Informatics Technology. Let me take you through my abstract to give you a general idea about what my project is about and how I plan to solve it. What my project, the problem my project is solving and how I plan to solve it. So in sub-Saharan Africa, cattle farming is a critical source of livelihood for many communities. Farmers keep large herds of cattle, but it can be difficult to accurately count the number of cattle they have at any one time. Because of this, yes, planning is indeed made difficult, and so is decision making in terms of planning for the cattle. So you think about cattle activities such as vaccination, estimating milk production, the different problems, issues such as cattle rustling disturb the farmers in East Africa so much. So what I devised is a technique that uses artificial intelligence to first of all be able to recognize cattle. And after recognizing cattle, it's also able to keep a correct count of the number of cattle on the farm at a given time. This particular AI works with mainly three herds of cattle, three breeds of cattle, which include the Red Den, the Brown Swiss, the Holstein Friesian, Jersey, and Ayrshire cattle. So that is basically what my project is about. If everything goes according to plan, this can lead to more productive cattle, which ultimately leads to greater profits for the farmers. So we can have our farmers benefiting more from actually rearing cattle. So in the past, well, we have seen various technologies being used to replicate the same idea. We have seen the use of RFID tags. We have seen the use of cattle tags. We have seen the use of implants. But all of these come short because they're quite expensive. Hiring a veterinarian to have to insert these devices into over 1,000 cattle is quite expensive. So you'd rather have them monitored and controlled using this AI, which is more cost efficient and works on an even larger scale. As mentioned in the existing method, the procedures have proved to be greater negative implications. We have looked at very expensive installation costs. We have also the breeds of cattle chosen after the majority of popular choices are kept by East African farmers. So the breeds that I chose to work with are the majority of the breeds that are actually kept by East African farmers on a commercial scale. For example, the Friesian cattle. The Friesian cattle is kept by the different farmers in the Kenyan highlands, produce milk and supply milk to Kenyans, including the Jersey cattle and the Red Den cattle. So the main contributions of my paper include the system has tested and can verify these different breeds of cattle. As previously mentioned, it's going to keep farmers' cattle more secure. It's going to help them keep track of the livelihood of their cattle and be able to plan accordingly according to these numbers. I'm going to take you through my dataset description. As previously said, my dataset is basically categorized into 5. It has 25 breeds of cattle, including the Ayrshire cattle, brown Swiss, Holstein Friesian cattle, Jersey cattle, and Red Den in those respective numbers. These are the statistics for the different breeds of cattle in that histogram. Then, in addition to that, I split the data set into 967 files for testing and 241 files for validation. For AI model selection and optimization, well, I used several deep learning models that were deployed to classify the 5 major breeds of cattle, which include the VGGI16, which is explained there below, the ResNet 50, including exception, DenseNet. These were very important in optimizing my model, and they help me yield more accurate results in overall. The results from my training are shown below. The validation loss and validation accuracy shown in the charts, and also an example of a prediction that was done. Here it was a Red Den cattle labeled, but so was the model. The model was also able to accurately predict that it was a Red Den cattle with that percentage, which is fairly good. So my dataset and Python source code are there, and these are my references to which my work was connected to. Thank you, and glad that you learned something today.